Hello, everyone. I'm Prabhat. I'm the founder of OpenObserve, an open source observability company. And it's fun today. Out of four of the sessions today, two of them were in observability, and many more are going to be on observability today, later in the day. So let's talk more about observability. What we have done at OpenObserve, and I'm going to share some of the insights around that. We started back in 2022 and building OpenObserve. And prior to that, I used to work for AWS as an architect, helping AWS customers design and deploy systems on top of AWS. And I found the common theme of challenge around observability. So I left AWS and here I am. And we tried a couple of things. We looked at existing systems built in different programming languages, including Java, Go, C+, and realized that the new kid on the block is Rust. It wasn't really that new, but for the purpose of observability, it worked very well. And we'll get deeper into what we get by moving to Rust for observability. First thing first, when it comes to, let's go to the very basics. What's the goal? Okay, what do we want from an observability system? Improve visibility and be able and reduce MTTD and MTTR. This is our goal. How do we do it? By looking at logs, metrics, traces, a couple of profiles, real user monitoring, and more. What are the non-functional requirements? This is where the challenge starts in. There are approximately 5 dozen observability tools out there in the world today, probably more. These are the ones that I can count off. Most of them would provide these things, the functional requirements of logs, metrics, traces in one or the other way. The challenges actually start in when you got to ingest all of that data, be able to query all of that data. Very basics. Write that data and read that data. When you want those dashboards, are those dashboards loading? When you're ingesting that data, when you're storing that data, is that costing you so much that you're like, okay, I don't want to do that? So these are some of the things that we look forward to solving. We actually did not really start with Rust when we started building OpenObserve. We started with Go and very quickly realized the deficiencies of Go uses garbage collection for memory management. And because the amount of data that we were ingesting was very high, we needed the system to be very efficient. And one of the problems that we found was that we had no control over memory because it is being managed by the runtime. Okay. Similar problem with Java is what we have seen. What we also seen is the very high resource consumption in terms of CPU as well as memory, which essentially is the root cause of extremely high cost. So we did a couple of experiments before moving to Rust. So we did some experiments in Go and Rust, comparing both of the what we are getting in terms of performance and resource utilization. For the same kind of code, literally same algorithm, we found that the code that was written in Rust was approximately 2x higher in performance, much better memory control. We were not at the mercy of the runtime when it came to memory management. In Go, memory would spike up like anything at times. And we couldn't really do much about that. And when we wanted to, we could actually do things, but then it got so complicated that, okay, why are we using Go at this point in time? We could actually use C+ or Rust, which provides much better performance and a couple of other benefits. What we also found was that Rust has a great ecosystem. And one of the great libraries is Apache Arrow Data Fusion. You guys got to check this out if you don't already know about it. So Apache Arrow Data Fusion is a project that allows you to build a database from scratch, okay? A new database for a specific purpose, okay? Imagine building a new database. You got to decide on what is the format of the data in which you're going to store the data. Then you'll have to build a query layer, okay? Where you'll have to define what query language you're going to be building, how you're going to be parsing the queries that users will write. Those things are very hard things. And Apache Arrow Data Fusion provides you that capability at the ground level. And you can take that and build on top of it. And because of that, there are many more projects are spinning up in Rust, specifically on top of Data Fusion. And when we picked this up, there are a couple of things that we got. We got very high performance of Rust in the form of data fusion, we're able to get the building blocks for building the database, which was the storage layer, where we stored it in the form of a Parquet file, which is a columnar storage, and which makes our analytics extremely fast. What it also allowed us to do was to be able to leverage SQL as a query language. One of the problems of building a database is always a new query language. Who wants to learn a new query language? Not me, definitely. And every time I've used a system which gave me a new query language, I was like, why? SQL makes life easy. That is what we got. So when we implemented this at OpenObserve, what does it look like? There are a couple of things that we did. The standard stuff for collecting telemetry data, we started supporting all of them: FluentBit, OpenTelemetry, Vector, FileBeat, Logstash, anything, or the direct APIs. What you get is a single binary or a single container for the ease of use. Run it under 200 MB of RAM. You'll get logs, metrics, traces, dashboards, alerts, real user monitoring. Okay, that's all under 200 MB RAM. We can't really get that. We could not have gotten that all of these with any other programming language. And had we not had the ecosystem of Apache or Data Fusion, not only a single node, but we were able to build an entirely distributed system. Of course, what we got from Data Fusion and Rust was something at a single node level. We had to build the entire distributed engine from scratch that worked at scale. I'll not really go into this for now. We can discuss this later, where you can talk to me later around this. But what we wrote a couple of things. And what we also thought was that when we were building this, my experience from AWS was that I used to recommend Elasticsearch for logs. And my customers used to be happy, but 3 months later, they would come to me and say that, hey, Prabhat, did I do anything wrong to you? Why would you recommend Elasticsearch for logs to me? And I was like, okay, I'm sorry. Okay. But what we also realized was when it comes to high volume, one of the best engines or systems out there was Spark, Apache Spark. And we modeled to a great extent OpenObserve on that. So we are much closer to, in terms of architecture, closer to Spark as opposed to Splunk, Elasticsearch, or any other system. We have decoupled ingestion and query layers, and we've got a compactor and a couple of other things. But at a high level, these are the things that we have. Now, how does it look like? You've got your data sources, the usual stuff, using any telemetry forwarder, any log forwarder, metrics forwarder. You're able to forward pretty much anything to the system. Data is stored in the streams. Think of them like Elasticsearch indexes. You're able to modify data in real time or in batches using pipelines, build visualization, alerts. Okay. And for the most part, all of this, if you were to try it out under 200 MB of RAM, that is what the benefit is at small scale. We have people who are running OpenObserve on Raspberry Pis. We also have people running OpenObserve in clusters of 500 plus nodes in Azure, GCP, and AWS. There's the kind of benefit that a system built in Rust, Data Fusion, and some more stuff on top of that provides. So we did a whole lot of this. What do we get? Extremely high ingestion and query performance. Most of the people who move from Splunk or Elasticsearch, we have seen people migrating. We have over 5,000 active deployments globally at this time. People have migrated from Datadog, New Relic, Elasticsearch, Splunk, and pretty much any system that I know of. Just to give you an idea, when people move from Elasticsearch, people say that they move from a 5-node Elasticsearch cluster or OpenSearch cluster to a single node of OpenObserve. That's on the compute and memory front. On the storage front, of course, that's a different story, which is a much lower storage again. Cost savings on infrastructure, 60 to 90%, depending on the use case. An extreme scale. Our largest customer ingests over 2 petabytes of logs every day, an aggregate of 60 plus petabytes, and are able to query that pretty efficiently. So some thoughts here. You really want to get rid of the observability challenges offered by legacy vendors like Splunk, Elasticsearch, anything built in Java is what I would say, which is difficult to manage. Rust changed pretty much everything for us. Had it not been for Rust, we would not have been able to deliver what we have delivered or what we have built. And we covered essentially what are the benefits that we are able to reap. So come and speak to us in the back. We are there. Okay. And that's all. Any questions?
Questions? All right, let's start at the front.
So if I compare your solutions, for example, today we are using the Dynatrace, right? Dynatrace almost does the same thing, right? And also has a Davis AI as anomaly detection. And I don't see anything AI related, right? Because when you are putting the ton of the data for the logging, tracing, and also the metrics, you need something at the back, right? To help you to detect the problems, right? Because we want to detect the problems before even happening, correct? So how do your solution, if I want to sell this product to me, for example, right? You're saying you bring the cost down, right? What do you mean by cost down? Because even your solution has a query language. My team, they have to learn this query language as well, correct? Because Dynatrace has its own query language. Elasticsearch has its own query language, right? Every team they have a learning curve, right? I guess your OpenObserve has its own query language that our team has to be learned, correct? How do you compare the costing, for example, with the Dynatrace that is kind of the similar product?
Great question. Okay. First thing first, cost is one factor. The primary advantages are around performance. And the first thing that with our biggest customer who ingests around 2 petabytes of logs every day, okay, they were running on Splunk. And they told us that they evaluated pretty much every system out over there in the Gartner's Magic Quadrant, including Dynatrace. It simply does not really work at that scale. That's the number one, scalability and performance. Number two, query language. OpenObserve uses SQL as a standard query language. Pretty much everybody already knows that. Okay. And if you don't know, it's easy to learn. Okay. Also, we have an AI agent that can write queries for you. For the most part, building alerts and dashboards, we offer drag and drop so that you can actually use. Of course, you can write more complex queries if you want. We also have anomaly detection built in that you can use. Okay. And while we talked about AI agent, which is in beta right now, should be available in GA somewhere around later this month or early next month. Yeah, these are the things.
Okay, thank you.
So we don't really compete, Prabhat. The cost is low, but that is a result of extremely high performance and extremely high efficiency.
All right, any other questions?
You mentioned it's running on a Raspberry Pi. That's the back end that's running on the Pi.
The entire backend and the front end.
Okay, cool. And that, I assume it's like inside of a container, or how's that running?
You can write a container.
Wow. Okay.
So this essentially emphasizes that the resource requirements for running a system. Yeah.
Any other questions? Anybody? Okay, I guess it was clear. Thank you very much.
Thank you.
Okay, so finished a few minutes early, and the burritos are on the way. They will be here in about 5-10 minutes, and they'll be served here. The other session is still finishing in the other room, the mini room. So yeah, that should be there around 12. And then we'll be picking up an hour later after we've all had time to have lunch and chat. Thank you very much.